Assalamu alaikum. Today we will move to section 2.4, one-sided limits. So the function f of x will have a limit L as x approaches C on if f is defined on both sides of x equals C and its values f of x must approach L as x approaches C from either side. Because of this, ordinary limits are called two-sided. If f fails to have a two-sided limit at C, it may still have a one-sided limit. That is, a limit if the approach is only from one side. If the approach is from the right, the limit is a right-hand limit. If the approach is from the left, it's a left-hand limit. So if the function f of x has right-hand limit L, at C, we write lim f of x as x approach C, and we put a plus on the top of C equals L. This plus sign just to indicate that we are approaching C from right side. If the function f of x has left-hand limit m at C, we write lim f of x as x goes to C from left side equals m. So the left side here is indicated by the negative sign. So plus and minus sign to indicate the side of approaching C, whether from right or from left. Because if I draw this number line, let's say, if this is the values of x, so let's say at x equals C, you can approach C either from right or from left side. This is from right side and this is from left side. So if x is going closer to C from right side, then we will say lim f of x as x approaches C plus. And if the limit is L, we write it L. If the function has a limit m, as we approach x from left side, then we will write lim f of x as x goes to C, and we write minus. To understand this more, let's have this example. Find the one-sided limits of the following function at x equals 0. So the function f of x is x divided by absolute value of x. We come across this function in chapter 1. It's called absolute value function. The graph of this function is drawn here, where if x is greater than 0, this blue colored line, the horizontal line, is for the function, and if x less than 0 for the negative values, the graph of the function is following this line, the blue colored one. So both of these lines represent the graph of the function. So as if the graph of the function consists of two parts. The right part here, or the part on the top, which follows values of x greater than 0, and this line at the bottom, which follows values of x less than 0. Now, if we want to find the limit of this function or the one-sided limits, so first we have to see the right side limit. So I'm going to write here lim f of x as x is approaching 0 from right. Why 0? Because the question is asking us to find the limit at x equals 0. So we will approach x equals 0 from right side. Means I am moving to x from right side. Okay? So what will be the value of the function? What is the value of y as x is getting closer to 0 from right side? The value of the function is going to 1. So we say the limit is equivalent to 1. So this is the right-hand limit. Okay? Now, if I'm approaching x equals 0 from the left side, we will write it like this. 0, on the top of 0 we put 0, means I am moving towards x equals 0 from left side. So as x is approaching 0 from left side, then I have to follow this line. So the value of y is approaching minus 1. So the left side limit is minus 1, the right side limit is 1. So these are called one-sided limits. So this is the right side limit, and this is the left side limit, or the right hand limit and the left hand limit. You can see here the two-sided limits are not equivalent to each other. Okay? Okay, let's see another example. Find the one-sided limits of the following function at x equals minus 2 and at x equals 2 at 2 points. The function is square root of 4 minus x squared, and this is the graph of the function. It's a semicircle. So let's see at x equals minus 2. So I'm going to find the limit, the two-sided limits of f of x as x approaching minus 2 first from right side. Okay? So x goes to minus 2. The positive sign from the right side means x is going towards minus 2 from the right side. What will be the value of the function? What will be the value of y? As x is getting closer to minus 2, you will find that the limit of the function is 0. The value of y is going to 0. How about lim f of x as x goes to minus 2 from left side? It's undefined. Why undefined? Because the function is undefined if x is less than minus 2. If I take you back to the definition here above, we said the function will have a limit at x equals to c if it's defined on both sides of c. Now, for this example, at x equals minus 2, the function is not defined from both sides to x equals minus 2. It's defined only if x is greater than minus 2, means to the right side of minus 2. But to the left side of minus 2, we don't have any graph here. We don't have any function. So we cannot say there is a limit. So as x is approaching minus 2 from left side, there's no limit. Undefined limit does not exist. It's better to even to say does not exist. We write it like this, does not exist. Instead of undefined, you write it D and E, does not exist, okay? It's better to write it does not exist. So we'll say does not exist, D and E, okay? Stands for does not exist. Okay, how about the at x equals 2? Well, we will say lim f of x as we approach x equals 2 from right side. Okay, to the right of 2 here in this region. Is there any function? No function. So what is the limit? D and E does not exist. The left side limit, lim f of x, as x goes to 2 from left side. Okay, I'm going to approach x equals 2 from left side. So as x is going to be very close to 2 from left side, the value of the function is dropping to 0. It's 0. Okay? So these are the one-sided limits at x equals minus 2 and at x equals 2. Okay? Don't be confused between these two on the top and this minus on the top and the minus sign in front. The minus sign in front of the number is for the number, but the minus sign on the top of the number means we are approaching that number from left side. The positive sign on the number, on the top of the number, is we are approaching that number from the right side. There is a theorem. The theorem says, this theorem number 6, a function f of x has a limit as x approaches c if and only if it has left hand and right hand limits there, and these one-sided limits are equal. So lim f of x as x goes to c equals L, if and only if. Sometimes if and only if we use these arrows, two-sided arrows. Means this condition will be satisfied if both of these two conditions are satisfied, or if both of these two conditions are satisfied, this condition will be satisfied. So this is two-way condition. That's why we write f and f, and in some textbook they write it like this, I, f, f. Okay? So the limit of the function f of x as x goes to c equals to L, if and only if the two-sided limits exist and they are equivalent to each other. Means the left side equals L and the right side equals to L. So let me take you back to these examples, and let's check if these functions has a limit as x goes to 0. Since the right side is 1, the right side limit is 1, and the left side limit is -1. These two limits are not equivalent to each other. Hence, we will say, the conclusion here, we will say lim f of x as x goes to 0, d and e does not exist. Why? Because the two-sided limits are different. How about this example? At x equals 0, at x equals -2, what is the limit of the function? Lim f of x as x goes to -2, also d and e. Why? Because the two-sided limits are different. One is having a value of 0, and the left side limit does not exist. The same thing here, at x equals 2. Lim f of x as x goes to 2, also d and e does not exist. So for the limit of the function as x goes to c to exist, both two-sided limits should be equivalent to each other. So this is the theorem. Let's have this example. Discuss the limits of f of x graphed below, including the one-sided limits at x equals 0, x equals 1, x equals 2, x equals 3, and x equals 4. So let's see. At x equals 0, let's find the two-sided limits at x equals 0. This is x equals 0. Okay. So let's see the two-sided limits. So we will say lim f of x as x goes to 0 from left side. What is it? From left side. See, the function is not defined in the region to the left of x equals 0. We don't have any function in this region, so the limit does not exist, the NE. Okay, how about the right side? Lim f of x as x goes to 0 from right side. As x is approaching 0 from right side, x is getting closer to 0, then the function is following this line, okay, and is going to 1. As x is getting closer to 0, the value of y is getting closer to 1. So we'll say the limit, the right side limit, as x goes to 0 is 1. Now, since the two-sided limits are not the same, 1 does not exist, and 1 equals to 1. So we will say lim f of x as x goes to 0 does not exist, because the two-sided limits are different from each other. Now, let's see at x equals 1. Well, at x equals 1, we have to find the two-sided limits also. So I will write here lim f of x as x goes to 1 from negative side, from left side. Well, this is 1. To the left of 1, the function follows this graph. To the right of 1, the function follows this horizontal line. Okay, we are talking about x from left, means less than 1, from left of 1. So as x is going closer to 1 from this side, the line is going down, so the value of the function is dropping to 0. So the limit here is 0. Okay, how about lim f of x as x goes to 1 from right side? If we are approaching 1 from this side, from right side, what will be the value of y? See, the value of y here is constant, 1. So as x is going closer to 1 from right side, the value of the function is going to this point, which is y equals 1. Okay. Now the two-sided limits are different. The left side is 0, the left side limit is 0, and the right side limit is 1. So since the two-sided limits are different, we will say lim f of x as x goes to 1 does not exist, because the two-sided limits are different. Okay, let's see as x goes to 2. I will write here lim f of x as x goes to 2 from left side. We are approaching x from left side. We are approaching x equals 2 from left side. Which part of the graph for this region, which is very close to 2 from left side? This line. Okay? So as x is getting closer to 2 from left side, the value of y is getting closer to 1. So this is limit 1. How about the right side limit? Lim f of x as x approaching 2 from right side. Okay. To the right of 2, the function is following this line. This line, not the horizontal one, this line. So if x is getting closer to 2, the value of y is going down to 1. Okay? So both the two-sided limits are equivalent to 1. So what we will say lim f of x as x goes to 2 equals 1 now. Following theorem number 6 here above, if the two-sided limits are equivalent, then the function has the same limit as x goes to 2. Okay? But let me ask you, what is the value of the function as x equals 2? See, the limit equals to 1, but the value of the function here based on the graph, because at x equals 2, the closed circle is here. So the value of the function at x equals 2 is 2. Okay? This is something different, the value of the function. We are talking here about the limit of the function. Okay, how about 3? How about 3? You find out the two-sided limits for at x equals 3, and you find that two-sided limits will be equivalent to 2, so the limit of the function as x approaches 3 is equivalent to 2. The last point here at x equals 4. The right side limit does not exist because the function is not defined when x is greater than 4. And the limit of the function as x approaching 4 from left is 1 because the function is going to drop to 1. So the two-sided limits are different. 1 does not exist. The left side limit equals to 1. Hence, the function has no limit. The limit of the function does not exist. So I will leave it to you, the last 2 points, 3 and 4. You can follow the same steps. Okay? There is a function involving sine theta and theta. Okay? So this function, sine theta over theta, which is graphed here, theta is in radians, okay? Not in degrees, in radians. So if the function y equals sine theta over theta, this is the graph of the function. Now, as x goes to 0, we will see the limit of this function. From the graph, as x is approaching 0 from both sides is equivalent to 1. So there's a theorem. The theorem says limit sine theta over theta as theta goes to 0 is equivalent to 1. Theta is in radians. Okay? Now, I want you to prove this at home. So this is self-study homework. Means you have to go back to the textbook or you search in the internet and prove this theorem. I'm not going to prove it to you. It's already proved in the textbook, and you can find the proof in the textbook. So you refer to the textbook or to any place in the internet and prove that the limit of sine theta over theta as theta goes to 0 is equivalent to 1. I want you also to prove this identity, okay, that cosine h equals 1 minus 2 sine square h over 2. This identity or this relation relates the angle and its half angle. See, this is the angle here is h. The angle inside the sine square here is h over 2. So you have to prove this. This is called one of the famous identities in trigonometric functions. Okay, I hope that you are familiar with sine and cosine and tan. These are called trigonometric functions. If you are not, then you have to go back and read about the trigonometric functions. Okay, you can find it in chapter 1 in your textbook, or you refer back to what you learned in the schools or in any learning resources. You will find a lot of information about sine theta, cosine theta, and tan theta. These are called trigonometric functions. So there's an identity or relation between cosine h and sine h over 2. I want you to prove this, okay? So we will use this theorem to solve some questions like these examples here. Show that limit cosine h minus 1 over h as h goes to 0 equals 0. And there is another example. Limit sine 2x over 5x as x goes to 0 equals 2 over 5. And also the limit tan t secant 2t over 3t as t goes to 0. You have to find that limit, okay? Well, I will solve the first one for you, maybe the second one also, and then I will leave the third one for you. Okay, so let's solve the first one. So we have to show that the limit of this function, cosine h minus 1 over h as h goes to 0 equivalent to 0, not from the graph, algebraically. Okay. Well, we have to use this formula. Okay, cosine h equals 1 minus 2 sine square h over 2. So we will say, this is part A, lim as h goes to 0 for cosine h minus 1 divided by h. So I'm going to use the identity above that you are going to prove at home and replace cosine h minus 1. Cosine h minus 1 will be minus 2 sine square h over 2. So it will be minus 2 sine square h over 2. Be careful, h over 2 is inside the cosine. Okay? So minus 2 sine square h over 2. If you move 1 to the other side, it becomes cosine h minus 1, which is equivalent to minus 2 sine square h over 2. And at the bottom here is h. Now, this is equivalent to limit as h goes to 0. This is minus 2 sine h over 2 multiplied by sine h over 2, because sine square, it means that this sine function is squared multiplied by itself. So I break it into two sine functions multiplied by each other. So sine square h over 2 will be sine h over 2 multiplied by sine h over 2. And then in the denominator we have h. Okay? From the limits laws that we learned, these will be lim as h goes to 0 minus 2. This is the first term, I will write it in a bracket, multiplied by lim, another bracket, lim sine h over 2 divided by 2 multiplied by a third bracket lem sine h over 2 as h goes to 0. This is as h goes to 0. So I break these functions into 3 functions multiplied by each other, and then we will find the limit for each. What is the limit for the first term? Yeah, limit minus 2. This is called the constant function. You remember the constant function? Limit k as h goes to c is equivalent always to k, because here there is no h, so the limit of the first function will be minus 2. The limit of the constant function is the same as the constant function. Now, let's see this term in the middle. If we are going to use this formula or this theorem, which says limit sine theta over theta as theta goes to 0 is equivalent to 1. Now, in our question here, we have limit, not theta, h over 2. This is supposed to be h, not 2, okay? This is h, huh? This is h, not 2. This h. See, if I divide the denominator by 2 and the numerator by 2, it's allowed for me. So if I multiply this by half, and multiply this by half means divide by 2, then the angle inside the sign is the same as the angle in the denominator. And if we assume h over 2 is theta, then this limit will be sine theta over theta, which is equivalent to 1. But don't forget to multiply by half. Then this is half multiplied by the limit of sine h over 2 divided by h over 2 as h goes to 0, it's equivalent to theta, is equivalent to 1. So multiplied by half, 1. So this limit is equivalent, half times 1 is 1. Then multiplied by sine h over 2 as h goes to 0. Now, if we use the direct substitution, if you substitute h by 0, then this is sine 0 over 2, that is 0. What is sine 0? If you use your calculator and you calculate sine 0 will be 0, okay? Sine 0 is equivalent to 0. So this will be minus 2 times half times 1, it's minus 1, multiplied by sine 0. So minus 1 multiplied by sine 0, that is 0. Then the answer will be minus 1 times 0 is 0. So the limit of this function will be 0. So this is the answer. We have shown that the limit of this function is equivalent to 0. I hope you understand the solution. Now for example P, this is a very simple one. Okay? We need to find the limit of this function, which is sine 2x over 5x. Sine 2x. 2x is inside the sign, over 5x as x goes to 0. And we want to show that this limit is equivalent to 2 over 5, right? Is it? Yes, 2 over 5. Well, I will give you a clue. Always, if you have sign number multiplied by x divided by another number, the answer will be 2 divided by 5. You just divide these two numbers. But to prove this for you, this can be done like this. Lem as x goes to 0, sine 2x. I want the bottom here at the bottom denominator. I want 2x, but we have 5x. So what you do is you multiply 5 times 2 times x. So I multiplied by 2, but I cannot do this unless I multiply the numerator also by 2. As if I multiply by 2 and divide by 2. Okay? Now this is equivalent to 2 divided by 5. Its limit is 2 by 5. Multiplied by lem as x goes to 0 for this function sine 2x over 2x. It's like sine theta over theta because 2x and 2x. And this limit is equivalent to what? Is equivalent to 1. So we have 2 divided by 5 multiplied by 1. This is equivalent to 1 according to the theorem above. So it's 2 over 5. So this is the answer. We prove that the limit of this function is equivalent to 2 divided by 5. Okay? So I will leave the last question for you. If you cannot solve it, we can discuss during the class. But to give you a hint for that, you use the relation for tan t. Tan t is equivalent to sine t divided by cosine t. Secant 2t is equivalent to 1 over cosine 2t. Okay? And then you have to use here cosine 2, you can keep it, cosine 2t, 1 over cosine 2t, and you can use the direct substitution. So I will leave this question for you, you can try. If you cannot solve it, then I will show you the solution during the class, okay? So I will stop here, and I will see you during the class, inshallah. Okay, bye-bye.